Hello everyone, welcome to this video lecture of TETLI Solution 2022. In this video, I'll be solving the questions of engineering mechanics. So let's get started. So the first question we have is question number 52. It says, two balls of equal masses and of perfectly elastic materials are lying on the floor. One of the balls with velocity v is made to strike the second ball. Both the balls after impact will move with a velocity. So this problem can be solved using the law of conservation of momentum, which says that momentum before collision equal to momentum after collision. So we can write m1 u1 plus m2 u2 equals m1 v1 plus m2 v2. The masses of both the balls are equal and the first ball moves with a velocity v. So we can write mv plus the velocity of second ball is 0. After collision, both the balls move with the same velocity. So mv1 plus mv1, or we get mv equals 2 mv1. M gets cancelled. So what we are left with is v1 equals v by 2. So our answer is option B, v by 2. Let's move to question number 53. It says moment of inertia of a circular section about an axis perpendicular to the section is So I have a circle and this is my x-axis, this is my y-axis, and this is my z-axis. So it says about an axis perpendicular to the section. That means we have to find I, z, z. We know for a circular section I x equals I y equals pi by 64 into d to the power 4. Now by perpendicular axis theorem, we can write Izz equals Ixx plus Iyy. Since Ixx and Iyy are equal, so we can write 2 times pi by 64 into d to the power 4. So that is equal to pi by 32 into d to the power 4. So our answer is option C. Now question number 54. It says two bodies of masses m1 and m2 are hung from the ends of a rope passing over a frictionless pulley as shown in the figure below. The acceleration of the string will be. So this problem can be solved using Newton's second law of motion, which says that summation of force equals mass times acceleration. So we have to use this equation for these two masses individually. So let's start with mass m2. The forces acting on this mass are weight, which is m2g acting downwards, and tension force of the string acting upwards. The acceleration acts in the upward direction. Now by Newton's second law of motion, we can write T minus m2g equals m2a, or T equals m2a plus m2g. Similarly, for the second mass m1, we can write weight m1g acting downwards, tension of string acting upwards. The acceleration acts in the downward direction. So we can write m1g minus t equals m1a, or T equals m1g minus m1a. Let's call this equation 1 and this one equation 2. So from these two equations we can write m2a plus m2g equals m1g minus m1a. If I take a common, then a into m1 plus m2 equals g into m1 minus m2, or finally we get a equals g into m1 minus m2 divided by m1 plus m2. So this is my acceleration. So the answer is option A. Moving on to next question, 55. The ratio of limiting friction and normal reaction is known as, let's say I have a body lying on the ground. I'm applying a friction force F to move the body. The forces acting on this body are weight force in the downward direction and one normal reaction in the upward direction. So the ratio of limiting friction and normal reaction is known as coefficient of friction, which is denoted by mu. So our answer is option A. Question number 56 says, moment of inertia of a hollow rectangular section as shown in the figure about x-axis is, we know for a rectangular section Ixx equal to Vd cube by 12, but this is a hollow rectangular section, so in that case we just need to subtract this hollow part, so minus small Vd cube by 12. So that's my answer, which is option A. Question number 57. If a force applied at any point in its line of action and is still creating the same moment about any fixed point, say P, then the force is said to be a sliding vector. What is the name of this property? So the name of this property is called principle of transmissibility of force. Let's say I have a body and a force is acting at point P. So according to principle of transmissibility of force, the effect of this force can be felt not just at this point but at all the points in its line of action. So this is known as principle of transmissibility of force. Moving on to question number 58. If the gravitational acceleration at any place is double, the weight of the body will be, we know weight of the body is given as mass times acceleration due to gravity. Now if the acceleration due to gravity is doubled, then we can write m into 2 times g, which becomes 2 mg. So our answer is option D. Question 59. Center of gravity of a solid cone lies on the axis at a height of a solid circular cone This indicates the height of the cone. The bottom portion is known as base and the top portion is called apex. The CG of a solid cone lies somewhere here, which is at a distance h by 4 from the base. So our answer is option A, 1/4 of the total height above base. Now question number 60. The angle between two forces when the resultant is maximum and minimum respectively are. You know the resultant of two forces P and Q is given by root over P square plus Q square plus 2PQ cos theta. Now the resultant to be maximum, the value of cos theta should be maximum. That is, the value of cos theta must be equal to 1, and this is possible only when theta equals 0 degree, and in that case the resultant R is nothing but the summation of the two forces P and Q. And for the resultant force to be minimum, the value of cos theta must be minimum. That is, cos theta must be equal to -1, and this is possible when theta equals 180 degree, and in that case the resultant is nothing but the difference of the two forces P and Q. So for maximum case, if this is my P force, then the force Q also acts in the same direction, so the angle between the two is 0 degree. And for minimum case, if this is my P force acting in this direction, then the force Q must act in the opposite direction, so the angle between the two is 180 degree. So our answer is option D. Let's move to question number 61. Vergnon's theorem of moment states that if a number of coplanar forces acting on a particle are in equilibrium, then Vergnon's theorem states that the summation of moments of all the forces is equal to the moment of the resultant force. So our answer is option D. Let's move to question number 62. Which is the correct statement about law of polygon of forces? Option A. If any number of forces acting at a point can be represented by the sides of a polygon taken in order, then the forces are in equilibrium. Option B. If any number of forces acting at a point can be represented in direction and magnitude by the sides of a polygon, then the forces are in equilibrium. Option C. If a polygon representing forces acting at a point is closed, then forces are in equilibrium. Option D. If any number of forces acting at a point can be represented in direction and magnitude by the sides of a polygon taken in order, then the forces are in equilibrium. The answer will be option D. The first three statements are incomplete statement. Only the fourth statement is a complete statement. So that's all for now. Thank you for listening. See you all in the next lecture.